So I'm going to start from scratch. So do it. Alright, so first thing we need is the grid of points, the reference points to create all of our vector field within. So the way that I do that is by using a box array, because that just creates a three-dimensional array based on a box. So grab a domain box. Let's use this one. Chuck that in there, and then set the domains all to 0 to 1. Oh, sorry. Use a panel, so the talking marks 0 to 1. Caps lock. Let's plug all those in there. And the base plane just leave as the standard XY. We might need that as a reference later, so I'll just put that there. And we want to keep that origin as 0, 0, so then we know exactly where it's going to go in space. Alright, so then X, Y, Z counts. We don't want too many to begin with. We can expand this later. So I'm just going to start with a slider that goes from like 5 to 10 at the moment, just so we don't crash. And up to you if you want to just use different parameters for these. I might do a different one for Z. And then the geometry that you put in. We can use those planes. I think we'll change that plane into a point just so that we're not arraying planes everywhere and it'll get all messy. So now we've got our grid. And if you wanted to see, so if you use point list, you can see the numbering of the grid if you want. Kind of. I need this. Okay, all my points and labels. Oh. Yeah. So you notice that it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's how it normally arranges the grid. So you notice it goes X, then Y. So up that row with X, up the next row with X. X is this direction, Y is that direction, and then it'll go, once it gets to 24, all the way over there, because we've got a 5 by 5 grid, 0 to 24 is 25 points, and then it goes up to Z, and it arranges it like that. Does everyone have that? Is it the domain thing? Yeah.
The Axstone says the box of. Oh, sorry.
Yeah. I just use 0 to 1 because the grid of these can just have a 1 spacing. It doesn't really matter at this stage. You might want to scale it according to what sort of object you want to put in it or something later, but yeah. Yeah, so yeah, this was more just to show you that it's an array of points. We don't really need the labels. It's just going to clutter things. I'll just hide this as well, so you right click, turn the preview off. Okay, so now we've got all those points. Great. Next, so in the vector tab, we've got a field tab here. I'm just going to go to point charge. And we want to just throw in a point somewhere in that grid and reference it in. Okay, so now we've got the point there. Did you get the point? And then you'll notice that we've got a few arrows around here. So that gives it, so this is a point charge. And we can change that charge positive or negative. Here at neg10, this is a cool trick for your sliders. We can create sliders really quickly, and if you want float precision, just put 0.000, whatever, and then you'll get that. Yeah, it looks like it just sort of unitizes the charge with those arrows, but at least you get the direction. Alright. Now, we want to use evaluate fields at a point, and then throw in your fields, and what happened? What did I miss? What the hell? I missed the key component somewhere. Oh, right. No, it's fine. Yeah, so you're evaluating the field at all of your points that you've arrayed. And then to visualize the field, I usually use the vector display, which is that one, so that you can sort of color it nicely. And is everyone able to follow? You're all good there? Yeah. Where are you at? You got the grid? I'll just drag this across, and then you can see. Because once we get to this point, then we can have a play around a bit. So the points are the geometry, the vectors are the tensor, the color is optional. Wow. Okay, so if you want an explosion, explosion of wind. Yeah, and then so you can change the charge on that point so that it attracts or it repels. Okay. So this is like static particles attracting to an object. There's the electrostatic charge to attract, and then do you guys, Patrick, do you have anything that explodes in your environment? No? Okay. Just in case you wanted to blow something up, you can do that. So those really big arrows are really, really close to that point, and then the arrows get smaller and smaller as you go out. Yeah. So then it eventually slows down. So, yeah. Okay, so that's the charge thing. Link, where are you up to? I'll let you catch up. Let's pause this. Please do. Gradient. So a gradient in there. We need a remap so that's the value, and we need to set up a domain. So sorry, construct domain, and oh no, what am I doing? Bounds. That'll give us the upper and lower limits of the output from the vector field. So the biggest vector versus the smallest. We put that into the source, and the target is just 0 to 1. So then those map values will be from 0 to 1. And then we just throw that into the parameter for the colors, chuck that into the colors, and then we get different colors. I'll just hide that so we can just see the color. Alright, so that's just that bit there. So that's bounds, remap. Alright, so at this point now that we've got the colors working, going to make the grid a bit bigger. So then we can see more of the effects that are happening. I'll just chuck this more or less in the middle. Woo. Okay, charge. So when you go charge 0, it does nothing. All your vectors become 0 again. But the vectors that are really, really close to your charge get huge, even if you just go to 1. But if you make this grid bigger, I'm pretty sure that changes. So I'm going to, let's go up to say 30 by 30 or something. Yeah, that sort of scales more or less based on the size of the grid as well, a little bit. Alright. What's easier to see? There's probably a bit too many, right? I'll go back down to like 12 or something. Okay. So now if you want to, so whatever. Alright, so this is one effect that you have for vector fields. I'll just group that and say that is point charge. So that gives you an explosion or static charge to your particles, basically, to retract to that point. And in here there's a whole bunch of other ones. Right? So I reckon the most exciting is the spin force. So I want to jump into that one. I'm going to leave this active for now because I want to add in another component here so that we can combine effects, which is the merge fields. So then you merge these two. Flatten that and chuck it in there. Alright, so it's at the default position at the moment, so it's just twisting the edge. I'm just going to chuck it on the same point for now. And then I'll put this on 0, so we get no effect from this one. Or you can just sort of Control E or right click, disable it. Either way. And then we get the twisting effect. And then you can set the strength. So we want to go from neg, probably, yeah, around about that would be useful for most things. Whoa! Whoa! Whoa. Okay. Bounds as well. Bounds for the fields. So we can, let's try the bounds thing. Sorry if it's hard to hear, but we'll work with what we got. So, say if we just wanted the swirly action to happen inside that box. Yeah. Okay. I think it's because this is not there. Cool, yeah. So now everything is affected by the point charge, but only the vectors within the box are affected by the swirling action. Does that make sense? So then you can say which parts of your vector field you want to swirl, which parts you don't want to swirl. And you can obviously use different points as well. So let's disable that box. I'll just delete it. And so Ray, I broke it. What happened? I broke my fields. Recomplete. What the hell? Oh, everything broke. Restart. No. Oh, maybe. No, because this isn't linked to anything. It's just not showing the display. Wait, let's save this. And when this happens, sometimes if you don't want to close Rhino, you can go Grasshopper unload plugin and then start it again.
Good, you remember, I don't. But again, subtle.
No, it's a Rhino thing then. So, probably should have saved that. Doesn't matter. My laptop is killing me. Except for the graphics card. That just. So. Oh. The arrow got too big or something. Okay. So now we're back. Okay, we need a point again. So point. Wow.
No worries, you are welcome. How's it all going now? Oh, crazy VectorFields.
Oh wow, that's so crazy. It really shouldn't be that crazy. So that one.
Okay.
Okay, is the radius. Don't make your radius negative. That was dumb. Okay. So there you go. So the radius makes it obviously spin tighter or looser. So it affects more or less of the grid. And then the decay changes the sort of linear decay of that. So if you go negative, it actually gets stronger as you move away from the point. If you go positive, yeah, it gets really, really small. So 0 is the same strength of twist everywhere, and then negative stronger, positive quicker.
Yeah, it's pretty good to mine, right? Yeah, it's just like, it's not super,
So yeah, you can change a few of these things until you get what you need. So if you need something sort of spiraling slowly in the middle and then accelerating out like that, or if you need something really fast in the middle like that and then slowly spiraling out like this, then you can change it with this. So if I just make the strength a little bit, you can choose which way it goes with the strength, negative, positive. Yeah. There we go. Something like that. Okay, so let's choose another point. Throw another point in the field somewhere. And then notice this is a plane input, so you can specify which plane the rotation happens on. So at the moment we're on XY. Let's just change it to say XZ or something. And then we'll have a look down this way, and we can see how it changes in 3 dimensions.
I don't know. The tutorials, but yeah, I'll just ask
Okay.
very much appreciated.
Be very careful of cables, guys.
Yeah, that was great. You did the job. You got it. You changed it. What you did. And everyone's work's going to be so much better for it. So thank you very much. You and Lars worked really hard.
Alright. So what do I need to do to make this better? working. I might put this on the edge so it's a little bit clearer about what's happening. So then you can see on that top surface. Yeah. I'll just, yeah. Yeah, I'm recording. Oh yeah, just close Rhino and reopen it. What are you doing, man? Oh, you power. Yeah. All good. Yeah, so now it's pretty clear. Yeah, Marcus.
Yeah.
Try and speak smaller. Sorry, man. I'm trying to focus. The vector field of your voice is too intense. Okay, so we get the idea of the twisting thing. Okay, so you can imagine tornadoes and that sort of thing, but there's one more effect that I want to show you, and then we can sort of freeball it a bit. Line charge or vector force. Let's choose vector force. So this is line. What? Oh. What's the difference between those? Ah, okay. The charge is the amplitude of the line. So let's just either one does the same thing. Alright, so let's get our -10 to +10 1 for our charge, and then the direction, we want the direction of the wind. I'm going to go with Y, so that's in that direction. Oh, for some reason there has to be a line. Oh, right, I know why. It's because it's using the line as like a charge as well, maybe. Let's just use the same point as we did for the rotation. Okay. Don't matter. And then which one? Ah, you want names? That's easier, isn't it? I keep forgetting that that's way easier when I teach. It drives me nuts with just like the amount of space that it takes. Yeah, anyway. Is that all good now? So SDL line, so start direction length line, and then line charge, starting at the same point as your spin force. Just going to group these up. Control G. Alright, and then chuck that one in the merge fields. And then we can change the charge on that, so then should be getting more and more sort of that way. I'm going to move my point to that. Not what I want. What do I want? I think I'm going to make the start point of that vector fields the line charge at that point. Okay. I think I understand the difference from these. Yeah. So the line charge versus vector charge. Let's see what the difference is. Control, get rid of that one. There we go, that's what I wanted. Okay, so the vector force. So now we have to use the length. Yeah, so it literally just gives you, like, it just adds another vector in that direction, so we get wind basically. Yeah, and then we can create the vorticity in the wind from our rotational device. So if you imagine that your wind coming down this direction, then you'll be able to sort of twist around in a vortice a little bit. I think we want to probably want to twist in another plane as well, not just in the XY plane. We can just add in another plane there. Oh, it's in the XZ plane there. Let's twist in the XY plane as well. Use the same point. We should be able to just chuck that in there. There we go. Now we get the stuff happening sort of three-dimensionally, right? Yeah. Let's get a point charge happening in there as well, just to see. Whoa. Okay, so imagine, where's my point charge? There. So if there's an object on the ground plane that is statically charged, the wind is coming there, the wind is twisting in the wake of that object, and that can be anywhere because that's just that wind direction. Getting a bit crowded with all the vectors, but we're going okay. Oh. Unintentional toggle. So I'm just reorienting myself. Okay. I think where's the global coordinate system? There. Yeah. Right. So if that's your origin for this vector field, take note of that, because you place your actual object in here, then you want to export the vector field and the object in the same position. Just take note of where those positions are. I think it might change a little bit with Unreal. Yeah. Or maybe not. Because I think X. I'm about 80% sure X is in this direction and Y is in that direction. Hopefully it's the same. Okay, so once we've done that, and we've got our sort of you know, vectors pointing in all the right directions that we want to create some sort of effect. Then I wrote a little code thing on the other one. Very simple code. If you want to learn a little bit of Python, I'm happy to show you it. Sure, okay. Let's just do it from scratch then. Does everyone have in their math component this one? Python script? Yeah? Cool. Let's do some Python coding. Alright, so what we want is from this tensor, we've got a list of vectors. So that's the tensor output. So these are basically all your vectors within the field. All there. Alright? Okay, so what we want to do is change the format of this into something that looks like 0 point whatever blah blah, etc. So that would be the first vector, and then we would do that again, and again, and again, and again, a lot of times. So then we end up with some sort of file that kind of looks like this, but without the line endings. So it looks like that. Should just wrap around. So it's going to look like a bit of jumble, but it's apparently the way that they format vector fields for Unreal. I think it's called like an FGA format or something. So basically what we want to do is take that and make it into that. And the easiest way to do that is with Python. You can also use C# or VB within Grasshopper, but Python is by far the easiest, especially for this task. So yeah, you don't have to deal with private or public variables or anything. Python just works. Yeah. Cool. What's wrong? What do you mean? What happened? Yeah. What do you mean? How can anything be wrong? What are you asking me?
What's that?
Yeah, that looks good. That's fine.
Oh, okay.
Your velocity for your line chart. Oh, you've got 2 line charges. Maybe just disable that one. And this one, you want to change the length of to something less. Otherwise, your wind would just way too strong. Yeah. I don't think that is any good. Just use that one. Oh, actually, unless you have a jet.
Yeah.
Like function of the tip of the jet, then you can concentrate the vector direction. So big arrows here in one particular direction, and then it will fade off. Come on. Alright. Okay, so little intro into this. So when you double click on this, you get a little Python script editor. And as your first script, all you're going to do is x equals, a equals x. And we just hit test, and it says execution completed successfully. Cool. But we don't know what happened really. So you can put anything in there and see what you get on the other side. Yeah. Our first code. It doesn't matter what you put in here. Python will be like, it's data. Cool. Here's some more. Here's the same thing. The thing with C# or VB, you have to actually define the variables in a certain way. Yeah. So that's why Python is so easy to use. But it's easy to make this. No. I'm not going to make any more general comments about Python. But yeah, you can put anything in there and you'll get the same thing out, right? So if I put this panel in here, I should get that panel out. Right? Yeah, it's the same thing. Yeah, just a equals x. Yeah. Now the thing that you want to do for this particular one is you want to access every line of this list, because the problem we have here is that every line in this list is like in a different data stream, if you like. So if you wanted to create something like this where it's all on one line, you can't really do that within Grasshopper unless you use a code. Or yeah, it's really, really convoluted. There will be some way, but it will be horrible and really inefficient. So unless someone created a component like this, I don't know already. But yeah, anyway, it's a good learning exercise. I'll just get rid of that other variable. We only need one. So the first thing that we want to do is get list access to this. So at the moment, what this component is doing is calculating every time it sees a new indice. So every list variable, it's running in a sequence. So it's doing line 0, 0, line 1, 1, 2, 2, etc. But what we want to do is grab the entire list and access that entire list within the component and do something with it, rather than just taking 1, 1, 1, 1, 1, 1. So what we need to do is right click on the X and go list access. Yeah, so then that changes the way in which we can then manage this process. So if I go square brackets indices 0, what that means is that I'm just accessing that first line there. Okay. And then I just get one line out. Okay, so x0 is that one. And now, let me see, what happens if you go 0 again? Okay, we get a curly bracket. Okay, so this is where Python's strength in not defining what a variable is breaks down a little bit. So it doesn't know that it's a vector. It just thinks it's a string of values. So that indice at 0 is the bracket. If we go back in here and go 1, we'll get that first number of that value. So this is a string. But if we change this, type hint to vector, what are we doing? Vectors? Yeah, Vector3D. Then it returns the number. So I've got indices 1, which is that number, indices 0, which is that one. So at 0, 0, here's that, right? So the first one is the line, 0, 1, 2, 3, etc. The second one is the axis within the vector, so 0, 1, 2. Okay, so next thing that we want to do is change this to a string using str, and then we can plus or concatenate something onto that string. So if we test that, we get this again, but with a comma. Now this is a string, it's not a float, and it's like the first little bit of what we want to create here. Okay. And then can anyone suggest how we would go about getting the next number and the next number? Yep, great. So just plus 0, 1, and continue that. 0, 2, and we'll test that. We should get that first vector like so. Same numbers, but yeah, just the commas in the right positions that we want. Okay, great. So we got the first line. Okay. So now the next bit that we want to do is replicate this for every line. So where this says 0, we want it to go 0, 1, 2, 3 all the way down to the very end of that list. All the way down to 1439. Yeah. And the way that we do that within coding language is using, say, a for loop. So you can say for I in range 0 to length of x. So that gives you, has everyone used a for loop before? Like in Arduino or anything? Yeah, yeah. No? Jackson? Is this new or?
Yeah.
Yeah? Okay. So a for loop, let's, I'll introduce one that comes before a for loop, so I'll just comment that one out. The first sort of looping statement, so something, or conditional statement rather. Okay. Within coding language, any coding language, right? This applies to C#, VB, C++, Python, doesn't matter. Don't get that worried expression off your face. It's a very simple concept. As soon as you nail this very simple sort of fundamental concept, you can expand it to do anything. Okay, so basically if x equals 1, then we're going to say print some string x is 1, or like 1. Alright, so we test that, it should still work, but instead of putting all of those values in there, I'll just grab a 1 and put it in there, and it freaked out because it's has the list access thing. I'll just comment out the rest. Come on. There we go. Alright, so when I print something, you know, when I hit print, it gives me something out of the output. So that's like just a error checking sort of thing. So you can just write little messages to yourself and little comments when certain things happen. So if x equals 1, print x is 1, and then you can do the, I think it's elif. So that means else if x equals 2, then print x is 2. And then you can do something if anything else happens. X is something else. Yeah, so I'll just put a number slider there. Yeah. So if we see this output, x is 2, x is something else, x is 2, x is 1, x is something else. Okay, so it's only going into this little line of code if that condition is met. Okay.
Is it same syntax with good not or there's a different syntax?
Pretty much the same. So processing is like this: if condition that, and then curly brackets, print. Oh, you might do print line and semicolon at the end, and then put in your x is 1. Sorry, this is processing. Yeah.
What this could answer?
Nothing.
What is after 2? That's 2 dots.
2 dots, yeah. So the colon, yeah. So they use the colon there, and then a tab. So they tab in. So that tab in is the equivalent of the curly brackets. So you know, so I go back to this line here. It's just all the way to the left, no indent. That's the equivalent of putting your curly brackets in like this, and you would put that like okay, but Python doesn't need that; it just needs the indent. So much neater, and you don't have to like forget curly brackets or anything. It's just it's just there. Okay, so that's a conditional statement. So that's like one of the fundamental things that you need to code. I'll keep that here so that you can have a play with it later. I'll just copy that up. I have to redo this step. Let's put this back into Vector3D. Okay, so we don't need that. But yeah, so for the for loop, there are these conditionals with coding. That was the if statement sort of thing. You can do a lot with that. Another thing is loops. So this is a type of loop within a code that just keeps going over and over and over and over again until a condition is met. So in this case, when you say for I in range 0 to length of x, it means execute whatever comes within the next tab over and over and over again until you reach the last item in the list. Does that make sense? So it's true, like the condition is true until it gets to the end, and then it's false, basically. So it's like a conditional, but it's sort of repeating something until the condition is no longer true. So we get to the end of the list. So what we want to do is place all this there, but change all the first zeros to I, because then we'll be going from 0, the first one, to the last one in the list. And then if we test that, let's see what we get. So you'll notice that we get, it's probably the last one. Yeah, so we just get the last one. Not exactly what we wanted, because right now it's just overwriting every value in A. So then it only shows the last one, because it's just like deleting what A was and replacing it with the new values. So what we need is just a plus equals there. What that does is something called appending, which just adds to the list. It just keeps adding. So as soon as we do that, I think we get an error. Yeah. That's because Python doesn't know what sort of type it is. So you have to say A equals, say, like an empty string or something. So you have to initialize it first. Make sure that's empty. So it's just two talking marks like that. And if you test it, that should work. And then you end up with exactly what we're after. So that output is in the correct format for Unreal. Yeah, and it's just 3 lines of code. Cool. But it's doing a lot. And yeah, I think it's a pretty good introduction to what you can do with Python, for instance. But it's like nowhere near the extent of its capabilities. Okay, so once you've got this is your, I think it's FBA. So what you want to do is right click on this panel and go stream destination. Wow. VROW 0.fda. Okay, and then once you're happy with your vector fields, you right click. So stream destination, you just set up where you want it to save, and then stream contents. It'll actually stream to that destination, and then there it is. And I'll open it up in program, and then there's your vector field. Oh, so many numbers. So then you should be in a position then to just choose that file within Unreal. So the way Marcus showed you, just choose, yeah, it's literally just set up the vector field module, local vector field or global vector field, whatever, and hit on the tab on the right that says find the file in the folder and point it to this, and it will load it in. Fingers crossed. So we haven't done anything wrong. So yeah. Does anyone have Unreal on their laptop? Yeah. Everyone does? Cool. I don't. But, so maybe create your own FGA file. Huh? Maybe there's like too many vectors. How many vectors do you have?
9.
That's not too bad, but that's probably what it is. You probably I don't know what the memory allocation is for Grasshopper when you're coding. Maybe it's that. I don't know. I came across that error as well, but it was only when I increased the number of vectors. So if you decrease the number of vectors, see what happens. Yeah.
Just keep going.
You gotta. So good test. You need plus. Plus. Oh yeah, but yeah. So sometimes it'll show you. So yeah. So unexpected taken before string meant that it actually didn't see what it wanted to see. Yeah. I'm gonna stop that video there.